This is Java Best Practices, Tools, Performance, and Deployment. So thanks for joining us this morning. I'm James Ward. I'm an evangelist here at Salesforce. And if you're a regular to these Salesforce webinars, this one we wanted to try something different. We have some real Java experts here at Salesforce and friends of Salesforce. And so we wanted to do something for Java developers. So that's what we're going to be diving into today. So with us on this webinar, we have Joe Kuttner from Heroku and Bruce Eckel from MindView. So Joe, you want to say hello?
Hi. Yeah, as James said, I work at Heroku. I'm the JVM languages owner, which means I'm responsible for not only making sure that all the JVM languages work on the Heroku platform, but also that they fit well within their respective ecosystems.
Great. Thanks, Joe. Welcome. Thanks for being here. And we also have Bruce Eckel. Bruce, you want to say hi?
Hi. I guess I've always focused on programming languages, so I spent a lot of time with C++. I was on the standards committee for 8 years and then wrote Thinking in Java, and then James and I wrote a book on Flex,
yeah,
right before they canceled the language, so we don't do closed source languages anymore. And then I also have a book on Scala with Diane Marsh called Atomic Scala.
Great, welcome. Thanks for being here. Okay, so as you know, if you've been in a Salesforce presentation before, we have a safe harbor statement. Basically says that we may say some things that are forward-looking in this presentation, and you should not make any purchasing decisions based on those things. Salesforce has a number of social channels. There's you can find us on Twitter as Salesforce Devs, and then on Facebook, LinkedIn, YouTube, and Google+. So check out us on the social channels for great information to help you become a better Salesforce developer. So in today's webinar, we're going to be doing things a little bit different from normal if you're regularly on these webinars. We're going to be doing Q&A at the end for about 20 minutes. And so we're going to have a really kind of extended period of time for some deep Q&A. We've got some experts here today. And so we're going to have a lot of time for that at the end. We will, a couple times during the presentation, see if there's any flaming questions we need to address, maybe have some discussion as we go as well. But stick around for the Q&A at the end. But you don't have to wait until the end to put your question in the webinar. You can just go in and enter your question anytime that's going to a queue, and we'll be looking at that queue and hopefully getting everyone's questions answered at the end. So here's our agenda for today. We're going to start out, I'm going to talk about Java tooling, the sucky parts. I did a blog post recently about some kind of hard places that we're at in the Java platform, and some things that we've just been doing some way for a while that really should be different and could be a whole lot better. And so it's called Java the Sucky Parts. And so I'm going to be talking about tooling and some parts of the Java tooling ecosystem that could be better and ways we can make it better. And then Joe will talk about Java deployment, the sucky parts, and then we'll do that extended discussion in Q&A. So that's our agenda for today. So let me just dive into Java tooling, the sucky parts. So one of the things that I've found in a number of enterprises is that getting new developers up and running with a project takes way too much time. There's these 10-page wikis that go through all the different steps that are needed to get a project checked out of a source control system, set up all of the runtime, set up everything that's needed, configure a bunch of things, install a bunch of things, and then finally run a build and start up the application and deploy it. And the big problem with these 10-page wikis to set up these development environments is that the wikis usually get out of date from reality. They're not maintained well. And this can lead to a lot of problems in how we actually move through a development cycle. If I'm onboarding new developers in a certain way, and then those developers we've made a change to the server that we're deploying to, then that change could be out of date with what's actually in the documentation. That could create problems with deployment, really could result in a it works on my machine kind of thing. And so the way that we can get around this is make it so that your build tool actually deals with this. Getting a project up and running in your system should really be no more than install a JDK, clone or check out your project from source control, and run the build to start the application. And that should be it. The build can do a whole lot of things to make this easy. The build can provision resources that are needed, like set up databases. You can use in-memory databases. There's all sorts of ways to really simplify this down. The goal that I think everyone should aim for is that a new developer should actually be able to be productive on their first day and be able to send a pull request or make a check into an SCM on their first day. That's really the goal that we should be aiming for, and it's definitely attainable. I've worked on a lot of projects that have focused on this, made this a priority, and it's possible.
In fact, you and I just spent a few days working on a setup tool.
We did, yes. Bruce and I embraced this recently, and we built something called the Gulp Launcher together, and it helps us do exactly this in the Node.js ecosystem. So there are certainly ways to do this in the Java ecosystem, and some of the ways to do that in the Java ecosystem are with the activator tool from TypeSafe, and then the Gradle tool has a great way to have this sort of system. And then if you're in the Node.js ecosystem, check out Bruce and I's Gulp Launcher, because it's the exact same thing. So let me just give a quick little demo here of what this actually looks like or can look like. I have a project here on GitHub. This is a Play Framework Java application, and it follows this philosophy where I should be able to, as a new developer, check out this project from source control and then run the build and be up and running instantly. So let's actually just go try that out. I'm going to go copy the git URL here, and let's go to my desktop, and I'm going to do a git clone, paste in that URL. So it's checked out of SCM. Now let's go over to that project, and now everything that I need to run this project is right here. All I have to do is run /activator and then run. This will download all the dependencies of the application and actually run the application locally for local development. This project uses a local database, so even though I'm using a database, I didn't have to provision that. I didn't have to go through a step to set that up.
So is the activator doing that?
Activator is running the project, and the project starts the in-memory database. So now the app is up and running. Let's just go check it out. If I go to localhost 9000, it's now going to compile the application, and then we'll see everything is up and running. And I know this is a very simple project, but enterprises can embrace this sort of mentality and be able to set up a project with really a maximum of 3 steps. Install the JDK, check out from SCM, and then run the build, exactly what you just saw. So we can test out this application. I can add some data to the database. There we go. We see everything's working. Okay, so that's the first idea that I wanted to go through, was the 10-page wikis to set up development environments suck, and we can make it a whole lot better. The next one, kind of related to this, is that incongruent deployment environments suck. I've done things. I've learned a lot of these lessons because I've done things the wrong way. And I used to, in the past, have a production application. The way that I would deploy that production application was I would run my build on my local machine, which would create a WAR file. I'd take that WAR file, I'd SCP it to a server, I'd SSH into that server. I'd have to actually take that WAR file that was my artifact to deploy, and I'd have to unpack the WAR file, so unzip it, go in and make a change to the web.xml file manually to change my database connection string or something, and then repack the WAR file, and then copy it into Tomcat and restart Tomcat.
So wait, you were doing that on the server?
Yeah.
After you copied it there.
Yeah.
Couldn't you have created a script to do that?
I probably could have, but what we want to get to is let's create a artifact to deploy that we can then move through our different environments without making any changes to it. It's an immutable artifact that I can take as a standalone thing and never have to change as it moves through environments. What this does is this helps me have a lot better insurance that I'm not going to break something as I move across these different environments. So let me show you an example of how we would do this with my little application here that's up and running. The one strategy that everyone in the Java world can embrace to do this is to move your configuration into environment variables. Environment variables are a really easy way to manage an application configuration that changes across environments without having to change that artifact like I was doing with that WAR file. So I'm going to go in and make a few changes to this application, and you'll see how we can actually start to use this sort of thing. This is the comp file for my application. I'm going to set up a new configuration here called foo. I'm going to set it to a string, and then I'm going to also say that foo is equal to the environment variable foo. And this syntax, what it's actually saying is only override that default value that I've set here, only override that if this environment variable exists. If I didn't want to deal with if it doesn't exist thing, then I could take off the question mark. So that's how I'm going to set up that environment variable, which allows me to have a default for local development, but then as I move to a different environment, I can set that environment variable foo and change the configuration of my application.
Can I ask a question?
Yeah.
A question came in that said, doesn't Maven do the deployment for you?
You definitely can use Maven plugins to do deployment for sure. Yeah. The typical process that a mature continuous delivery type of application would go through is that I'm going to always check into my SCM, do a pull request, get something onto, let's say, the master branch, and then my CI system should be continuously taking changes that are happening on master, rebuilding them, rerunning my tests, and then producing an artifact that then I can either automatically deploy or manually deploy onto a server. So yeah, and you can do that through a number of different build tools in the Java ecosystem: Maven, Gradle, Activator, which is SBT that I'm using for this project. Lots of different ways to do that. Okay, so I've got my configuration. Now let's go actually use this configuration. So I'm going to go edit the views and then index Scala page. And now I'm just going to display the value of this configuration, not incredibly useful, but let's go put in here play.application.getString, and then I'm going to tell it to get that foo configuration string. So let's go try this out and make sure that this works. If I refresh the browser, it's going to recompile that, and there we see there's my configuration variable ASDF. So that's my default configuration. Now let's say I'm going to run this in production. Well, all that I have to do to change this value in production is set that foo environment variable. So I'm going to say foo equals, set it to a different value, rerun this application with a different set of configuration and different environment, and then once this compiles and runs, we should see, when we go up here and refresh, we should see now that new configuration variable once it finishes recompiling. There we go, we see it. So now we've overridden our configuration, which in a way that allows us to take an asset and move it across the different environments without changing that artifact. Any other comments or questions, Bruce?
Let's see. Oh, somebody was asking, are optional environment variables a standard, or is that part of Activator's filtering?
That is a part of a project called TypeSafe Config, which Play Framework and Eckel use as the way to deal with configuration, manage configuration. But Spring and the same thing can be done in Spring, where you can have a default and then override that default with an environment variable. So I've seen that done in Spring with environment variable binding. Okay,
yeah,
next
I think that's worth pointing out that.
Go ahead, Joe.
That one of the advantages of these environment variables is that they're super portable. So not only between platforms, whether it's Windows or Linux, but also between frameworks. So this same configuration can be consumed by Play or Spring or even Node.js.
That's a great point. Once you set that environment variable for like a database connection string, it could really be used by any language, any framework. It doesn't matter. It's agnostic. Great point. So next one is that manually managed dependencies suck. I, again, have done this wrong a number of times where I take a jar file and just copy and paste it into web and lib, and then I have that dependency. The problem with that is that, one, I don't know what version this is. I don't know if it's the right artifact. Somebody could have unpacked it, made some changes, and repacked the jar file. We need to move to a system where all of our dependencies are actually coming from an artifact server. The two primary artifact servers are Artifactory and the Nexus server from Sonatype. And so you can use the open source libraries, which are on Maven Central, a central Maven repository of open source libraries. Or you can also set up your own Nexus or Artifactory server for your own libraries. So the way that you, in a large organization, should be dealing with these dependencies is to, one team can be putting their dependency up into a Nexus or Artifactory server, and then another team can be then consuming that down. Then you get the ability, and you should use immutable releases. So when you actually pull something out of this repository, you should use a versioned, immutable release of a library. One of the other benefits of managing these dependencies in this way is that then you get transitive dependencies. Transitive dependencies are when one dependency depends on another, and that is managed for you by all the standard Java build tools. So Maven, Gradle, SPT, they all will manage the transitive dependencies. And this is the way that I used to do this. The really wrong way that I used to do this was I would take a jar file, I'd put it into my webinf lib, and then I'd try to run my project, and I'd get a class not found error because some transitive dependency didn't exist in my class path. And so then I'd have to go search around on the web, figure out which library has that transitive dependency in it, copy the jar file, put it in my webinf lib, and try again. And there's a whole lot of issues with this approach. Instead, just let your build tool manage your dependencies for you. So let me just show you how we do that in this particular project. There's a file called build.spt, which defines all of my library dependencies. So you can see that I'm depending on H2, which is the in-memory database. I'm depending on Spring Framework in this particular one, the Hibernate Entity Manager. But now I've specified all these dependencies and their versions, and so those are now going to be pulled down into my project. And these are all publicly available open source dependencies. You can do the same exact thing for dependencies that you share across your organization. So pretty simple concept, lots of different ways to do it in Java between the different build tools, but very important to manage your dependencies in this way instead of trying to manage them manually. Questions or comments, Joe or Bruce?
Let's see. No, I don't think anything through here.
Okay. So next one, last one I want to talk about on tooling side is that long development and validation cycles really suck. I've, again, done this wrong a number of times. There have been projects that I've worked on where just to see a simple change in the HTML page that I was working on, it required a 5-minute process of rebuilding war files, redeploying war files, restarting Tomcat, and that really hinders productivity. So it's really important to use tools that give you a flow that can make it so you can validate your changes very quickly. And the flow that I use now is I make my code changes, my tests automatically rerun when I make my code changes, and most of the time I have it set up so that if I'm working on a web application, my browser even automatically refreshes so that I don't even have to go refresh the browser manually to see that change. And this creates a really phenomenally fast workflow. There's a number of different tools you can implement this with. The tool that I use a lot is Play Framework. It has this capability built into it, but you can also do this with tools like JRebel. And then a number of other frameworks support this flow as well. So let me just show you a quick example of how I do this with Play Framework so you can get an idea for what it looks like. So I'm going to come in here and go to my app and then controllers, and then I have an application.java file. So this is my Java source code for this application. Let me just go make a quick little mistake here in the code. So I'm going to save this file, and now when I go back to the browser and hit refresh, Play is automatically detected that there was a change to that file, has tried to recompile that file. I got a compilation error, so I see that change right there in my browser, and now I can go back, I can fix that, make that change, hit refresh again, it's going to recompile, and now I see my page again. Same thing would be true if I'm editing templates or editing configuration or whatever it may be. All I have to do is hit refresh, or if I use the Play Auto Refresh plugin, it does this for me automatically. I see the change. And then on the testing side, I also usually will, instead of, in addition to running my application, this is running the web application, I'll also automatically run my tests. So to run my tests, I do that activator and then tilde test. The tilde says run my tests, and then whenever there's a change, rerun the test. And so this allows me to be much more test-driven, be able to be automatically rerunning my tests and seeing the output of my tests happening all the time. So you'll see I actually broke a test at some point by making a change somewhere. So something is broken, I should go fix it. But it did run my tests, and they obviously failed. So I could go in and fix that. So it looks like 1 failed, 8 passed. So, but then if I go in and make a change, it'll automatically rerun these tests, and we should be able to fix everything and have a really nice development cycle. Okay, so definitely, I showed one tool, but there are definitely other tools that you can use out there to have the same development flow in Maven-based project and in Tomcat-based projects. Joe or Bruce, anything to add to that?
No, nothing appropriate.
Okay. All right. So that's what I had to say for the tooling part. So I'm going to hand it over to Joe, and he's going to talk about deployment and how we can make Java deployment a whole lot better. So Joe, let me give you control of the screen, and then you can take it over. 1 second while I find you in the list. Where are you in the list?
Well, we can always. We've got the phone number of our marketing person, so we can always call her and let her do it.
We can. Nope, I got it. All right, Joe, should be handed over to you in just a moment. I think I'm seeing your screen. So.
All right. Yeah, you see the various JVM languages there?
I do. Yep.
Okay. Yeah, I did want to point out that we're talking about Java, Scala, whatever, but I think a lot of these principles that they apply to all the JVM languages. I will focus.
Can I say something? Your slide's broken. You're missing Python.
Jython.
Yeah.
Jython, right?
Yeah, I'll go back and correct that with pull request to Jython.
Thank you.
Bruce is a big Python fan.
Oh, are you? Okay, I didn't realize that. Well, I'm sorry.
Deeply offended.
So I'm going to focus on Java, but again, a lot of these things we're talking about across all of these languages. So the first thing to think about when talking about Java deployment is traditional war file deployment. And going along in the vein of James, what parts suck, this is the sucky part of Java deployment. So the traditional way of getting your Java applications out into the world is to package them up into a WAR file and then drop them into a running servlet container, whether it's like Tomcat or something heavier like JBoss. And this was a really good solution 10 years ago. I think this method of deployment was first introduced in 1999 with the Servlet Spec 2.1. But that was a time before the cloud. It was a time even before virtualization. So this method of deployment was solving problems that were different from the present day. So before jumping into this kind of method of deployment, I think it's important to ask why do you do this? And what problems does it cause? Because I think as as James mentioned, with long deployment cycles, it can make your iterations slower because you have to repackage this thing. It makes it difficult to do incremental compiles and things like that. It also makes it difficult to have congruent environments because most shops that I work with, they don't want to run a fully packaged WAR file in development. It slows things down. So when it comes to modern Java deployment, what does it look like? And ultimately, that means it's containerless. So what Java frameworks are starting to move towards is getting rid of servlet containers like Tomcat or JBoss that are sitting outside of your application and sort of inverting the model and putting the thing that binds to a port and handles HTTP requests inside of your application. So modern Java deployment looks more like this. Package your application up into a jar file, maybe an executable jar file, and then deploy it anywhere that has a JVM. That's the only dependency between your application and the platform that it runs on. So that could be the cloud, it could be Heroku's platform with a JVM, it could be a Docker container, some other kind of virtualized environment. And this is the sort of methodology that a lot of the new frameworks that are emerging and old ones are starting to embrace. So Spring with Spring Boot is embracing this containerless approach. Play, as James kind of already demonstrated, just sort of does this for you. Finagle and Netty take this sort of embedded approach as well. So I'll go ahead and show a demo here. I don't do live demos well, so I pre-record mine because I make too many mistakes. But what I'm going to show is an example of using Spring Boot. And let me know if you have trouble seeing this video. So I have a simple project here with a POM.XML and a proc file, which I'll explain what the proc file is in a moment. And then a single Java class, which is basically the entire application here. So if I open up the POM.XML, you'll see that it's a pretty standard POM.XML. It has a few dependencies, primarily on the Spring Boot library, which will in turn pull in a dependency on Tomcat for me. Then I also define the main controller as the entry point for my application. So if I open up the main controller, you can see it's a fairly standard Spring class with the Spring annotations. But down at the bottom of this class, I have a main method. And in this main method, I initialize and run the Spring application. So this is what not only boots the Spring framework, but gets my application to bind to a port and start handling requests. And oh yeah, so zoom in there if you're ever in trouble seeing. So if I jump back over to the command line, the way I run this application is first by packaging it up with Maven. And because of the Spring dependencies that I'm using, it'll package my application into an executable jar file. And that's what this Spring Boot jar is here. So I can then run this application just by using a simple Java command. So java-jar and then the jar file. And when it boots up, you'll see Spring initializing. Also in there is Tomcat binding, initializing itself, and then ultimately binding to a port and starting to serve requests. So if I pop over to a browser, you can see this application running on 8080 localhost. What the application does really isn't important. It's just really the principles of the framework itself. So that Java command that I use to start the application, I can take that command and put it into my proc file. So that proc file is a file that's used to tell other platforms, whether it's Heroku or Docker, how to run this application. So in this example, you can see, I don't know if that's, let's see. Are you seeing the little play thing? Is that in the way for any of you?
I think it's okay.
Okay. So yeah, so I could take this proc file, add it to my application. I add a few other things like how to configure the port and how to provide some Java options. But then I can also create a Heroku application and run this application the exact same way I ran it locally in the cloud. So I'm using the Heroku tool belt here. Heroku provides this set of command line tools for creating, provisioning an application and deploying it. You can also do this from the browser, and I'll show that in a moment too if you're not super friendly with the command line. But then I can deploy this application to Heroku by pushing to the Git repository that it's provisioned for my application. So when I push my source code up, Heroku detects that it's a Java application, runs the same Maven task that I showed earlier that I ran locally, and then it takes all of the artifacts that were generated by that Maven process, primarily the executable jar file, and packages it up into a slug, which is used to run my application. So as soon as that's done, I can tail the log files here, and I'll see basically what I saw happening locally, happening now in the cloud. And I can open this application with the Heroku open command, and I see the same application running, but instead of localhost, now it's running on herokuapp.com. So really what this does is, by making my application bootable, that is an executable jar file, it also makes it portable and easy to distribute to various environments, whether it's Heroku or something else. But it also makes the application easy to scale. So I can run the Heroku PS command to see my application's process. So what this says here is there's one web process. It shows the java-jar command that I had defined in my proc file, and it shows that there's one process with a status of up. So because this application is very easy to run and doesn't require any other infrastructure like an application container, I can quickly stand up new instances of it. So if I run Heroku PS scale web equals 5, I will get 4 new processes running the exact same application. And if I run Heroku PS again, there you are. You see the other instances in a starting status. And I can easily scale them back down the same way. These are also disposable, so the other instances have no impact on the rest of the system. So this is the exact command that some of Heroku's customers use the day before Black Friday when they need to ramp up and expect a large amount of traffic. They can do it very easily, very quickly, and very cheaply. Another useful command provided by the Heroku command line is Heroku releases. Each time you deploy, you get a new revision for your application. So if you deploy breaking changes or something that causes your app to crash, you can quickly and easily roll back to a previous version. All right, so everything I've been doing from the command line can also be done from the Heroku dashboard website. So here's the application I just created. You can see the web process executing that jar file. You can see the 3 web processes running. I can scale these up and down just like I did at the command line. I can also view activity for the application. I can see when it was deployed, when environment variables were changed. I can control access, give other developers the ability to push to this repository, and I can also view metrics. So with no other code instrumenting my application in any way, I can see response times and throughput and CPU usage, and if there are requests timing out or things being dropped, I can try to correlate those to spikes in CPU or spikes in memory. All right, so one more thing I want to show from the command line before finishing the demo is the Heroku run command. So I can run a command on Heroku for my application. In this case, I'll start a bash shell, which stands up a new environment containing my application that's completely isolated, but still has all of the artifacts that were generated by the Maven process. So I could potentially run the same Java command here to start up the jar file. I don't know why I would do that, but more likely you'd do things like run database migrations or little one-off jobs. But again, this is happening in the cloud with my application. All right, so I'll jump back to the slides here. So a lot of the, well, actually, I'll give Bruce and James a chance to chime in on anything at this point.
Yeah, one thing to clarify is the server, the app server, is still there. Tomcat is still there. It's just that instead of being a external thing to the application, it's packaged with the application. And this helps to alleviate the it works on my machine, or for some reason it doesn't work on this environment but works on this other environment. A lot of times those issues are because there's something outside of the application that's running the application, the typical container model. Whereas in this model, everything that the application needs to run is self-contained. So yeah, it's still using underneath the covers the container essentially, but it's all packaged and bundled together to make it easier to, or more safe to move across environments.
Yeah, and there's a question here. Do you end up with multiple containers if multiple dynos are running?
So yeah, multiple instances of the application. So multiple servers running the application. When Joe scaled that application up, it was actually multiple servers each running the application with the load balancer load balancing the requests across them.
Yeah, so the disadvantage of that is that you, if you were trying, like, in the older model, if you're trying to deploy multiple applications into the same container, it's not as easy for them to share resources, but at the same time, they're not contending for resources in the same way. So it's a trade-off.
Yep.
All right, so this methodology of bootable applications that are disposable and can scale up very easily is what's called the 12-factor app. This is sort of a methodology for scalability and maintainability and portability of any kind of application, not just Java or JVM-based applications. It does this through clean contracts, declarative setups, clean contracts between your application, meaning your only dependency from the platform might be a JVM, reducing the coupling, and then a minimum divergence between each of your environments. So again, that congruence between development, staging, and production. So these are the 12 factors, and actually what James talked about earlier really covers some of these, like code base and dev prod parity and things like that. So I'll skip that one. I want to talk about concurrency. JVM apps and the JVM itself are very good at scaling up. You can throw memory and CPU at them, and they'll really handle it well. But our JVM apps also need to be able to scale out. And by that I mean essentially the Heroku PS scale command. You need to be able to instantiate more of these applications, whether it's for redundancy or just for handling more requests because tomorrow's Black Friday. This needs to be able to happen quickly and reliably. But you also need to be able to scale out by diversifying your workload. So if the old way of deploying into an application container really promotes monolithic applications in which worker processes or background jobs can't be scaled independently of the web processes. So it's important that these things be, whether you have background jobs doing some kind of work, pulling things off of the queue, that if you need more concurrency for that component, that you can scale it independently. Disposability is another one of these factors. This states that your applications should be fast to start up and graceful to shut down. Frameworks like Spring Boot and Play basically do this for you, and this is as opposed to application containers, which in many cases can take several minutes to start up. And I've seen shops using application containers where that several minutes in a cluster of 8 to 10 servers can make it very difficult not only to scale up but also to do upgrades and resolve replace nodes that have crashed. Another one of the factors is dev prod parity, keeping your development, staging, and production environments as identical as possible, as James said, to reduce the incident of unexpected problems. The most common place I see this violated is at the database layer. So we recommend at Heroku that if you're using Postgres in production, you should be using it locally as well. But this also applies to the application container. So I've seen a lot of shops that work with JBoss in production, but because that's too heavy and cumbersome in development, they'll use something lighter weight in development. And that should be avoided. And the best way to avoid it is to not have a container at all, so along with the containerless approach. I'll skip over logs. The last factor is admin processes. And the 12-factor app states that admin processes or management tasks should be run in one-off isolated processes. So what this means is that you should not be logging into a production server to run a job. I can tell you from experience that I've done this, logged into a production server to run a database migration, and brought down the entire application because I locked up the actual running process that was handling requests. So when I ran Heroku run bash, or if you run Heroku run console with Scala, you get an isolated environment where if you do something wrong, you're not going to trash the web processes. And ultimately, a bootable environment, a disposable environment, makes this possible. All right, so those are the 12 factors. James or Bruce, did you have anything to add to that?
I've been embracing the 12-factor app principles for the last 3 years or so since I was at Heroku and learned about them, and it's really made a significant difference for me in my production apps. It's made things so much more stable, and things would just, there was a lot of pieces before that were very vulnerable to breaking for various reasons, and the 12-factor app is really increased for me and my apps the stability and insurance that I have that things are going to work the way that I expect them to.
I couldn't tell if it was covered there, but one of my maxims is automate everything.
Yeah. Yeah, I couldn't agree with that more.
No. Cool. All right. Thanks, Joe. I'm going to take screen sharing back over and have a couple things to go through, and then we'll dive into some discussion and Q&A. So looks like that's working. So if you're on the call and you're in the Salesforce world or want to get into the Salesforce world, we have something called Trailhead. It's a new tool that we've created to help you learn the Salesforce platform. Check it out, developer.salesforce.com/trailhead. Really great way to dive in and get started. Also, there's a number of places where you can see tutorials and learn more. There's a Udacity course for Salesforce. There's a really great developer workshop from one of our other evangelists, Christoph. Make sure you check that out. And if you use this bit.ly link to refer a developer to Salesforce, then you will be entered in to win a smartwatch. So check that out. And then please take a moment and fill out a survey for this webinar. The link is there. I'll leave that up for a couple minutes, and we're going to do some Q&A and discussion. So I wanted to kick it off first to ask Bruce and Joe. We've talked about Java today and some really kind of ways to make Java development and Java deployment better. And there's been a lot of talk recently about Java 8, and so I wanted to get your guys' thoughts on what does Java 8 change for us? Is it ultimately making things better? What does it change for us in tooling and deployment and our experience with Java? Joe or Bruce?
I'll let Joe go first.
I really think Java 8 is it's bringing the love back to Java. I mean, for years I was searching for a new language to work with, and I did a lot of work with JRuby and things like that. But I think it's really, for me, revitalized my interest in the Java language itself. But aside from the language, the improvements to the platform have been really remarkable too. And it's really neat that it's so backwards compatible, because I can recommend just about anybody that's on 7 go to 8 and I have yet to see anyone struggle with that.
So you're okay with lambdas?
Yes, I am. Are you?
No. No.
What's the problem with lambdas?
Well, lambdas is it's a fake closure. And it doesn't do what closures are supposed to do, but it sort of pretends to be a closure. So I think it's
It's a pretend closure.
yeah, it's a pretend closure. It doesn't actually close around its surrounding variables. It's just it's an abbreviation for a function, which to go to that much trouble to put a feature like that in and not go all the way. I understand it's backwards compatibility, but it just doesn't feel like I don't know.
There's the difference between a closure and a lambda has to do with the state the this reference, or what's the technical?
Well, so a closure actually, so the idea of a lambda is that it's just a shorthand way to create instead of an anonymous inner class. You could do a lambda. A true closure creates a full, basically a fully functioning function by grabbing all the necessary variables around it and keeping their state, basically keeping them alive. And so if you're expecting that to happen, if you're used to using closures, you'll be surprised. So and it's very limiting. So it's like, I don't know. I find it disappointing. That's all. But I'm also not surprised because that's the way they do things in Java world.
All right.
Yeah, I think everything you're saying is correct. But it very much reminds me of the discussions we had when generics were introduced many years ago, and they weren't a complete implementation, and there were things wrong, but ultimately they were an improvement, and I think most people agree that they're a good thing that we still use and want to use.
Okay. Yes, we could go there, but
our generic improvement, I think, is the.
Yeah, I don't know if I wanted to dig that up, but.
Yeah. Well,
I think that certainly it is true that lambdas and generics are very similar in their how they have changed Java. Like
I'll agree with that.
Yeah.
Very diplomatic of you, James.
Thank you. Okay, next question. I want to talk about microservices. Microservices is kind of the big hot thing right now. And so how do microservices fit into this new world with Java, the modern Java world?
Could you give a brief explanation
Sure.
of microservices?
Yeah, so microservices, there are a lot of different ways to look at them. I look at them as being much smaller than a full application.
Okay, but they're on the web.
Not necessarily. Yeah,
Okay.
not necessarily. Some people think like, oh, actors are like the best microservice model because you can have an actor you send a message to and it does something, right?
Mm-hmm.
And some people look at service frameworks like Finagle as being like the ideal microservices framework. So I don't think we've fully hashed out exactly what it is. For me,
could you think of it as kind of like, well, we have libraries of functionality, but these are like alive instead of you having to put them into your app and get them.
That's a great way to look at that.
Okay.
Yeah. For me, I think microservices is much more around team orientation than it is around like technical things.
Mm-hmm.
It's taking a team of like 5 people and allowing them to produce an endpoint that stands alone, scales on its own, is deployed on its own, and then another team can then interact with that endpoint with a very clear line between the two. So I think for me that's the more compelling reason for microservices is around team organization and how teams own their own infrastructure. This is different from the typical enterprise model where a team of 1,000 people are all working in the same app in the same container possibly with other teams in the same container as well, with different apps, and it just makes things very brittle and slow, whereas I think microservices enables teams to move forward at their own pace with their own technology, with their own deployment schedule, and decouple from the traditional hierarchical model that we have with containers. So Joe probably has some insight into that, since I know Heroku really embraces the microservices model.
Yeah, I think you were starting to get towards what I was going to say, which is the idea of not having to bring down the entire application because your team is deploying a small component or something like that is one of the most promising aspects of microservices. But I definitely don't think it should be looked at as the end-all, be-all. I see a lot of the same problems there that I saw with service-oriented architectures when that was popular. It just maybe has better marketing. I don't know.
Isn't microservices kind of SOA 2.0?
Yeah, maybe. But regardless, I think there's a lot of things that
not to knock it.
Yeah, not and yeah, it definitely improves on some of the earlier thoughts. But even if you're not fully embracing the microservices methodology, I think there's aspects of it that you can take away. Like disposable applications, bootable environments, things, reproducible environments.
So, Joe, what were the problems with service-oriented architectures that you see also in microservices?
Coupling. You can't fool yourself into thinking that because we're standing these things up as their own little containers, their own little silos, that can't result in a single semicolon bringing down the entire infrastructure. That's actually a story that someone at Netflix talks about. A little microservice had a missing semicolon. It went down and caused a chain reaction that brought down everything else.
So yeah,
ultimately you have to get your interfaces right.
They don't necessarily isolate us from domino effects.
Mm-hmm. So yeah, you still have to think about your interfaces and ensure that they make sense and that you're coupling things in the right way where they should be and where they shouldn't be.
Mm-hmm. Well, yeah, actually, I don't see. If your system is a bunch of components that depend on each other, it doesn't really matter how you put them together. If one component is not working, how do you keep the whole system from coming down?
Mm-hmm. Yeah. And it becomes in a microservices environment, it becomes difficult to diagnose when that is a problem.
Mm-hmm. I suppose you could take the Erlang approach and just let it die and then reboot it.
Yep. Well, that's an interesting point, because I do think that microservices do enable teams to have ownership over their frameworks and their languages. And so one of the things I want to talk about is great, there's some modern ways that we can use Java and we can use not Java, and microservices kind of enable us to make those decisions at a much at my level rather than at the top of the management hierarchy. And I know Netflix really embraces this. It's like one team's using Groovy, one team's using Scala, one team's using Java, and they can do that because they have a microservices mentality, right? Mm-hmm. And so it enables them to choose the framework. So I'm sure there are people on this webinar that are like, this all looks great, but I'm never going to be able to convince my management to move to these sorts of things. And I think maybe microservices is the catalyst that you first need to embrace before you can have more ownership over your technology to be able to choose some of these new.
Yeah, it would enable polyglot stuff more easily.
Exactly.
But that's an interesting observation, because what you're saying may mean that the organizational structure you have to change a bit in order to allow microservices. That's just a conjecture.
Yeah, definitely.
Well, the nice thing is there's precedent. You can look at Netflix OSS or read about what Twitter's doing, and they're definitely embracing that and setting a standard, I think.
Cool. So we've been talking about Java primarily today, but there is a whole lot of other language options out there, as Joe pointed out, and as Bruce added Jython to the list. What does the future of the language ecosystem look like? Are people going to be embracing things other than Java much more than they were in the past? Where are we going with languages?
Well, I think in the past it was very common to have a monolithic language culture. It was possible to do that. You spent so much time figuring out and working with a single language that it was hard to think about multiple languages. But just from the case of the web, it's becoming more and more that our UIs are written in JavaScript or some language that compiles to JavaScript. And so everybody is, I think, being forced into the mindset of saying, well, we have some language on the back end, and our UI, even if we're just creating a local app, you're probably going to create your UI to run under a web browser. And so that's going to make people more comfortable with multiple languages and picking up multiple languages. So I think the languages world is probably just going to naturally become more polyglot and more experimental.
So as Java developers, we may not be able to just be Java developers anymore. We may have to be polyglot developers.
Yeah, I think so. I mean, I suppose in maybe larger organizations where people have more of perhaps a niche job. But see, I don't even think that's possible anymore. Look at the hiring environment now. It's so hard to get programmers that programmers themselves need to be more powerful because there's just not enough of them.
Yeah. Maybe this will be a fun way to wrap it up. We have a couple minutes left. I saw an article came out, said it was the 15 languages that you should know in 2015. 15 is kind of a lot. But so we'll start with Joe. Joe, what languages should I be learning beyond Java? And you can include Java 8 in this if you want. But what languages should I be learning and becoming proficient in 2015?
Well, I think it's important to have a language that solves particular problems. So, if you already know a scripting language, maybe you don't need to learn another one. But I think JRuby is always getting better. It has a new version, big new major release coming out this year, and it has great support by a lot of the industry. So I think that's definitely one to pay attention to. And of course, you can't ignore JavaScript. But choose your flavor of platform because there are definitely more ways to run it than just on Node.js.
Yeah, definitely. So JRuby and JavaScript, and of course Java.
Sure, Java 8.
Java 8. All right, Bruce, what do you think? 2015, what languages should I be learning?
Well, I think we had a pretty good example that Python is fairly useful because we ended up solving your problem using that.
The gulp launcher.
The gulp launcher pretty rapidly, and actually that I think what I find useful with that is that it just has a vast set of libraries both within and without the distribution. So very often, whatever problem you're trying to solve is already solved. Just plug the library in and go with it. Some kind of forward-looking thing on the JVM. Certainly, Scala's a candidate. I'm going to be digging into Kotlin. There's a lot of people who've been liking what's Lisp. What's the Lisp? Clojure. Yeah, a lot of people have been liking Clojure. Every time I've gone to a seminar that's talking about Clojure, they end up teaching Lisp and never really get to the parts that are unique about Clojure. So I'm still kind of vague on that, but I know people have a lot of excitement about that. Go is interesting. I keep being very interested in the Go language for some of the things that they're doing. I am currently looking at Erlang. It's kind of fascinating because it's almost as if it were a language that were made to develop web servers or web systems, server-side web systems. And let's see, that's all. Well, I suppose if you're trying to learn Scala, then what's the language that Scala's used based on?
Haskell.
Haskell. I mean, if you really want to get into
So
the kind of purist approach, I suppose you could look at Haskell and maybe understand monads.
Maybe understand monads.
Yeah, but then be unable to explain them to anyone else
right.
because
that's the curse of the monad.
That's James' curse of the monad.
Yeah. Great. All right. Well, we are out of time. I want to thank everyone for joining. I hope you got a lot out of this. The webinar video will be posted. We will email you that link so you can go watch it again. And thanks so much for joining, Joe and Bruce. We really appreciate your time.